Hi, Mr. Ortman here. In this lesson, we look at developing a general formula that will allow us to find the x-intercepts of any quadratic function. So for example, we know that if we take a quadratic function in standard form, ax squared plus bx plus c, we can complete the square to get it into the form of a times x minus h, the quantity squared plus k, which is vertex form, which allows us to determine the vertex, in this case hk, and also we could determine the x-intercepts. In order to do that, we would set f of x equal to 0 and then solve for x. So we've done that several times at this stage. So we set out now to look at developing a general formula that would allow us to determine the values of those x-intercepts without having to go through the process of completing the square each time. So in order to see where that formula comes from, and I warn you this is quite a lengthy process, but it's a fantastic algebra exercise, we replace the coefficients with general variables here a, b, and c, and then we solve for x. So the first step in that process is to complete the square. So to complete the square, we remember that we need to make the coefficient of x squared equal to 1. So we factor out the a from the first two terms. So dividing each of the first two terms by a gives me x squared plus b over a times x. We kick out the constant term. Next, we take half of the coefficient of the middle term and then square it. So if we take half of b over a, I'm going to do this off to the side here. So we have b over a half and square it. So doing that gives us b over 2a squared. And b over 2a squared is b squared over 4a squared. So b squared over 4a squared is the number I need to complete this trinomial square. And recall now, we need to determine what it is I actually added to the original equation. And what I added was this a multiplied by b squared over 4a squared. So that's the quantity that I need to then subtract out here. So again, let's do that off to the side. So if I multiply a by b squared over 4a squared, keeping in mind that a is the same as a over 1, then this gives me the ab squared over 4a squared. So a little bit of simplification here occurs if you think of the fact that you have two factors of a in the denominator, so one of those would divide out. So leaving you with the b squared over 4a. So it's the b squared over 4a that I need to subtract. Okay. So now I can rewrite that trinomial square as the square of a binomial. And that would become x plus, now keep in mind that this value right here is always equal to half of that, or it's the square root of this. So half of b over a was b over 2a. Okay. So the first part of our journey is complete now. So we have the vertex form of a quadratic function that is in standard form. So this would say, for example, just pausing here for a minute before we actually find the x-intercepts, the vertex of this general quadratic function would be equal to, or have an x-coordinate of negative b over 2a. Okay. Keep in mind that this represents the x-coordinate. So for example, if this was x plus 3 squared, then the x-coordinate would be negative 3. So in this case, I have x plus b over 2a, so the x-coordinate is negative b over 2a. And the y-coordinate, not so nice, c minus b squared over 4a. Okay? So what, just very quickly, what this would allow me to do is to take any quadratic function, for example, f of x equals, say, 2x squared minus 5x plus 7. And I can very quickly get the x-coordinate of the vertex of that quadratic function simply by replacing b in the negative b over 2a with negative 5 and the a with 2. So the x-coordinate of the vertex, we'll call it x sub b, is equal to negative b over 2a. So it would be negative, b is negative 5 over 2 times a. So I'd get 5 over 4, okay? More on that later, but you could find the y coordinate very quickly by replacing now x in the original function with 5 over 4 and then determining y. So more on that later. Again, our focus right now is just to establish a formula that will allow us to determine the x intercepts of the function. So back to this, okay? So now what we're going to do is we're going to set f of x equal to 0 to get the x-intercepts. Okay. So if I set this thing equal to 0, then I'm going to get a times x plus b over 2a squared plus c minus b squared over 4a is equal to 0. Okay. So what that would require me to do is to, again, I need to solve for x. So I'm going to have to get this onto the right-hand side and then get this onto the right-hand side and then eliminate the square and then get the b over 2a on the right-hand side as well. So let's do that in 3 steps. I think it's probably best if we try to combine this into one single fraction first. So let's do that. So keeping in mind that this is the same as c over 1 here, and so if I look at c over 1 minus b squared over 4a and I want to get a single fraction for that, what I could do is multiply top and bottom of the first fraction by 4a, trying to create a common denominator between the two fractions. So that would give me 4ac over 4a minus b squared over 4a. So that would give me a single fraction of 4ac minus b squared all over the common denominator of 4a. So going back here now, I could replace this with 4ac minus b squared all over 4a. Okay. So now, subtracting this fraction from both sides, again, trying to isolate the x here, gives me minus 4ac minus b squared over 4a. Okay, so I need to subtract that entire fraction. Subtracting a fraction, you may recall, is equivalent to either subtracting the numerator or the denominator. In other words, multiplying the entire numerator by a -1 or the entire denominator by a -1. Either one works, and just to get rid of that minus sign, I'm just going to multiply the numerator through by -1, which would create a negative 4ac plus b squared. Keep in mind, you have to multiply both terms here by -1, and when you multiply negative b squared by -1, you get a positive b squared, all over 4a. So that gives me a times x plus b over 2a squared on the left-hand side. All right, we're getting close now. So in the next stage, the next step would be to multiply both sides by 1 over a. So doing that gives me x plus b over 2a, quantity squared, is equal to 1 over a times this fraction, multiplying the numerator by 1, gives me simply negative 4ac plus b squared, and multiplying the denominator of 4a by the denominator of a gives me 4a squared. Okay. Next step would be to take plus or minus the square root, because I'm trying to get rid of that square, and we remember how to do that. Plus or minus the square root of this entire fraction. Okay. Now I'm going to just take a moment here to rewrite this numerator. Okay. Remember that addition is commutative, so that means that I can swap these two. I preferred the first one to be positive, so I'm going to write that as a positive b squared minus a 4ac. So same thing, all over 4a squared. Okay. And then I also recognize that I could square root the numerator and square root the denominator. You remember that the square root of a over b is equivalent to the square root of a over the square root of b. So using that property gives me the square root of b squared minus 4ac all over the square root of 4a squared. And the square root of 4a squared is, in fact, just 2a. So I get the square root of b squared minus 4ac all over 2a here. And on the left-hand side, I'm still left with the x plus b over 2a. Okay. So now I can see that if I were to subtract b over 2a from both sides, I'd get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then I have two fractions here with the same denominator, so I could combine those two, and that would give me a single fraction whose denominator is 2a. So my final formula here would be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is also known as the quadratic formula, and a very, very useful tool for us, which will allow us to solve quadratic equations, any quadratic equation, and also determine the x-intercepts of a quadratic function. So just two quick examples here of how you can apply this. Let's say that, for example, you wanted to determine the coordinates of the x-intercepts of, I've got two examples here. F of x is equal to 2x squared minus 3x minus 7. And another one, let's say we want to find the x-intercepts of negative 3x squared plus 4x plus 8. Okay. So, first thing we need to do, let's look at problem number 1. We need to identify a, b, and c in our quadratic function. So this is in standard form. So a is 2. So let me write that. A is 2. B is equal to negative 3. And c is equal to negative 7. So using our quadratic formula, I could replace now a, b, and c with each of those values. So I get x is equal to, this says to take the opposite of whatever b is. Well, in our case, b is negative 3, so the opposite of negative 3 would be positive 3. This says we need to square b, and if I square negative 3, I end up getting a positive 9. Let's just write that. And then a is 2, c is negative 7, all over 2 times a. So we get 3 plus or minus the square root. Now this is where we can use our calculator, right? So we've got negative 3 squared minus 4 times a times c. That gives me 65. So this is 3 plus or minus the square root of 65 all over 4. Now, square root of 65 does not contain any factors that are perfect squares, so it's already simplified. So my final answer here would be that the x-intercepts are 3 plus or minus the square root of 65 over 4. Okay, there are two of them. One's 3 plus root 65 over 4, and the other's 3 minus root 65 over 4. So these would be the exact values. This is the preferred answer. Of course, you could find decimal approximations of each of those. If you took 3 plus the root of 65 and you divided that answer by 4, you get one of those is approximately 2.77. The other one would be 3 minus the square root of 65 divided by 4, and that one is approximately negative 1.27. Okay? You might need that for the purpose of sketching the graph, okay? But we're not required to graph here, so we're good. Again, problem number 2, we identify a. A is negative 3, b is equal to 4, and c is equal to 8. So applying the quadratic formula, I take the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Simplifying gives me negative 4 plus or minus the square root. Taking 4 squared minus 4 times a times c, okay, gives me 112, all over negative 6. Okay. So, as a matter of fact, 112 does contain a factor that's a perfect square. You might notice that 12 is divisible by 4. If you take 112 and you divide it by 4, you get 28. 28 is also divisible by 4. Okay, so since I divided by 4 twice there, the original number 112 is divisible by 16, which is a perfect square. So I could rewrite root 112 as root 16 times root 7. All over negative 6. And root 16 is 4, so I get negative 4 plus or minus 4 root 7 over negative 6. Okay. Now, just to save a bit of time right now, and I'll explain more why this is true later, but as it turns out, you can simplify this entire fraction here if it's possible to find a number that divides evenly into each of these 3 numbers. So in fact, 2 would divide into each of these 3 numbers. So I could take a 2 into a negative 4. I could take a 2 into a 4. And I can take 2 into a negative 6. Okay. And furthermore, you could multiply top and bottom by a negative 1 if you prefer the denominator here to be positive. So multiplying both of these by negative 1. Multiplying negative 2 by negative 1 gives me positive 2. If you take the plus or minus 2 root 7, you multiply by a negative 1, what you end up getting back is negative positive 2 root 7. So it's the same thing. So plus or minus 2 root 7. And then, of course, multiplying the negative 3 by a negative 1 gives me a positive 3. So these are the 2 x-intercepts. So one of those would be, if I broke this apart just so that you can see it, would be that. And the other one would be, call x sub 2 minus 2 root 7 over 3. Okay, and again, you could find the decimal approximations for those. All right, well, I hope you followed that. Take your time, go through the lesson, and try some of the examples. Be sure to get your homework assignment off of Moodle. It's in the plan book there. And let me know if you have any questions. Okay. Thank you.